Right, looking at number 1 on our review, here's how I would tackle this question. If ABC is an isosceles triangle, I'm going to stop right there and I'm going to draw this thing. Okay, I know an isosceles triangle looks like that. I know I'm going to label A, B, and C, but I'm not going to label them yet. It says angle B is the vertex angle. The vertex angle is the angle that gets made by the congruent sides, by the legs of my triangle. So this would be my vertex angle up here, which means A and C are the other corners of my triangle. And then I'm told some information about the length of each side that I'm going to go ahead and fill in. I'm told that AB is 6x plus 3. I'm told that BC is 8x minus 1. And I'm told that AC is 10x minus 10. I'm asked then to find the value of x and the length of each side. I heard the sound of the light bulb going off, which is awesome. So from here, give me a thumbs up if you think that you can set up the algebra and do this on your own from here. We're just going to vote. If you want to see the algebra run, give me a thumb sideways. I'm going to go quick if it's a thumb sideways. If it's a thumbs down, I'll go step by step and explain. So let me vote now. I see some sideways thumbs, some sideways thumbs. Okay, and I've got a few down thumbs. All right, so we're going to set this up step by step. Because this is an isosceles triangle, these two sides are congruent, which means I can write their measures equal. So I can write 6x plus 3, which is the measure of one side, equals 8x minus 1, which is the measure of the congruent side. Solving for x, I'm going to move all the x's together onto one side of the equation. I'm going to select the right-hand side just because it avoids negative numbers. And there's my new equation. I need to get rid of that negative 1. I get rid of subtractions by using additions. And when I'm done simplifying, I have 4 equals 2x. Undo the multiplication by 2 requires me to divide, and so x equals 2. I've done this portion of this question. Now, if this were on the test as excuse me, as an open response, we would need to see all of the different sides. So I need to find the length of each side, and that's going to come next. I'm going to have AB, BC, and AC. Since x is 2, over here I'm going to replace x with 2 each time I see an x. And so 6 times 2 is 12. 12 plus 3 is 15. Without any additional work, because this is an isosceles triangle, now that I have AB, I automatically have BC. Looking at AC, I'm going to go ahead and substitute everywhere I see an x. I'm going to write a 2, and now I have 10 times 2 minus 10, which is 10. Because 10 times 2 is 20, 20 minus 10 is 10. Question like this as an open response would be worth anywhere from 2 to 5 points, depending on how much detail we're needing. Definitely one for setting up things properly, another one for finding the value of x, and then possibly another one for finding the value of all the sides. The next one that got the most votes was this one, number 3, the find the value of x with the hourglass. I'm going to zoom in on the figure. What do I notice about this figure?
It looks like an hourglass.
It looks like an hourglass. You're not wrong.
Lines.
One more time.
Parallel lines.
Yeah, we've got some parallel lines happening right here. With parallel lines comes a transversal, does it not? And I have 2 transversals. I have this one right here, and I have the one going the other direction. Doesn't matter which one you pick, you should get the same results. If I'm looking at this transversal, what kind of angles are these? Alternate interior, and alternate interior angles are congruent. Because they are congruent, that means their measures are equal, and so I can set up my equation this way. Nathan, take a look so you can see what I wrote. Alright, I'm going to solve this one for x. I'm going to start off by collecting all of my x's to one side of the equation. That's going to have me adding 2x here for the right-hand side. Excuse me. I'm going to get rid of the 51. And then divide by 4. All I was asked to do was find the value of x, and so once I found the value of x, I can stop. This question again worth likely about 2 points, more if asked to justify. 1 point granted for setting it up correctly, another point for getting the correct value of x. Questions on this one? Feeling really good?
Yes.
Good. All right, I'm going to zoom out for a moment so I can try to find the next highest vote. The next highest vote looks like it is going to be this proof right here. Before I get started on the proof, the question I have for you is what makes these proofs difficult? Is it remembering all the symbols? Is it knowing what all these words mean? Or is it trying to figure out what I'm supposed to put on the reasons? The symbols and the reasons. The symbols and the reasons. Okay, so let's clarify the symbols first, and then we'll clear up what we can write in the reasons. Okay? All right, so let's start with this symbol right here, the 2 bars. Yep, this means is parallel to. Okay, these little triangle shapes mean triangle. Yeah, it's a triangle.
What?
All right, I have the equal sign with the squiggly on top. What did the equal sign with the squiggly on top mean?
Congruent to.
Is congruent to. What did congruent mean?
Same.
Same size, same shape. And I really want you to specify same size, same shape, because if you just say it's the same, you mean it's the exact same shape. And it's not. These 2 pens I'm holding up are congruent. They're the same size and the same shape, but they're not the same pen. They're physically 2 different pens. Okay? Let's see, some other interesting symbols in here. We have this symbol. Yep, this symbol here means angle, and you may encounter that same symbol but with an S inside of it. That just means that we have more than one angle. Angles. All right, feeling a little bit better. Together turns into bitter. A little bit better about what the symbols in the proof mean. Okay, read the proof again now that you have what the symbols mean. Does the proof make a little more sense now than it did before? Good. Now the other concern that you guys had was what reason to write. Yes, for what we're saying. Okay, so let me see if I can try to make this a little more clear than we have in the past. If we look at our first statement, our reason is because it was given to us. And it says that L is the midpoint of JM. But let's pause there and think about what that means. L is the midpoint. What does that mean?
The middle.
It's the middle. It's right in the middle, which means what's true about this segment and this segment? They're congruent. Look at your next statement. They're congruent. Why did you say they were congruent? Because L is the midpoint. That's what it means to be a midpoint. And so we're writing the definition of midpoint. To write a proper proof, you're writing the name of the definition or the property or the postulate or the theorem or any of those. You're writing the names of it. But since you're learning how to write proofs, I don't expect your proofs to be perfect right now. So if you come to this and you go, okay, I'm stating that these are congruent, and I'm stating that because L is the midpoint, and midpoint is in the middle, and that's what you write for me, you've basically written the definition of midpoint. You just wrote it all out in words. That's okay, because at least it tells me what you were thinking as to why you were making that statement. And that's all you really need to put in a reason is why. And give me your best why. What is the reason? Okay? Because if it's way off, I can correct you and go, actually, this is this thing. Or if you have the right information, you just didn't give the correct name, I can give you credit because you've got the right thought. And then I can tell you, oh, the name of what you wrote is definition of midpoint. And then when you go back in your review and you look at it, you can go, oh, I'm writing the definition. Then you can save yourself some writing later and just write definition of midpoint. Okay? Does that help clarify what we're writing in the reasons? Yes? Okay, let's keep looking through this proof and finish it out. And that way we can answer these two questions that are down here. They basically have us answer these two spaces. Okay? All right, the next sentence, the next statement was given to us. And then it said that these angles, angle JKL, this one here, and angle MNL, this one here, it says they're congruent. And the reason it gave us is because they're alternate interior angles. So let's confirm. Looking at our diagram, zoomed in really close, we have a parallel line. And we have a transversal. The green angles, are they on the same side of the transversal or different sides?
Different side.
Which means they're alternate. Yes?
No, ma'am, Ms. Carranza.
Yes.
No,
Yes.
ma'am, your attendance for today, ma'am.
I'll get it to you as soon as I can. Thank you.
Thank you, ma'am.
So they're on opposite sides of the transversal, they're alternate. Notice how the angles are both between the parallel lines? That means they're interior. These are alternate interior angles, and we have a theorem that says alternate interior angles are congruent. Notice what was written. Alternate interior angles are congruent. They didn't write the name of the theorem. They just wrote what the theorem says, and that's acceptable. That's okay. If you wanted to write the name of the theorem, you would write 2.8 alternate interior angle theorem. Okay? Either one of those is acceptable. If you're pushing toward perfect proof, you want to put the name of the theorem. Right now, when you're working on just learning how to do them, you can just write your reason. Okay? All right, next thing that it says is that these angles, excuse me. The next thing it says is that these angles are congruent. JLK, this one here, and MLN, this one here. And we have to figure out why are those congruent. One more time. They're vertical angles. Hi, keep it on topic, please. Thank you. Those two angles are vertical angles. They're vertical angles because they're created by two lines intersecting, and they're across the vertex from each other without sharing anything else. They only share a vertex. We have a theorem that says vertical angles are congruent, so you could write vertical angles, you could write that they are congruent, or you could write the name of the theorem, which is the vertical angle theorem, as I write all crooked, because I'm out of room. Last but not least, we have that the triangles are congruent. Do we have enough information to say that the triangles are congruent? Yes. Okay, now we have to figure out why. I'm going to go to the very last thing we have in our notes. The very last thing we have in our notes is that we have 5 ways to show triangles are congruent. We can use everything about them is congruent. We can use the 3 pairs of sides are congruent. We can use 2 pairs of sides in an angle, or 2 angles and a side. All right, let's look at our figure. Looking at our figure, do we have all pairs of things congruent? No, we're missing these sides and we're missing these angles. Okay, so we're not going to use this one. Do we have 3 pairs of sides congruent?
No.
No, we only have 1 pair. Wait, we only have 1 pair of sides? Okay, so that means that one's out also. We're stuck with just these 2. So the question is, looking between these 2, this top one says the side has to be between the angles. And this one says the side can't be between the angles. What's our setup? We have 2 angles and the side that's not between them. See how we did that? And so the reason that these triangles are congruent then is the angle side theorem. I think I totally misspelled theorem. Sorry. And now we have our answers for these 2. Yeah?
Yes.
All right. Be prepared for the proof on your test to either be a proof where you have to fill in or a multiple choice proof. Okay? So be prepared for one or the other. All right, the next biggest vote was for this one. Likely because you see all these figures, these right here, and it intimidated you, yes?
Oh, yeah.
What you're trying to do is you're trying to match the statement with the figure. So what I'm going to do is I'm going to zoom in here, kind of close and kind of tight, and I'm going to go one at a time, and I'm going to start removing things that don't match what our drawing looks like. So our first one says angle L is congruent to angle P. Here's angle L with 1 marking. Here's angle P with 2. That's wrong. Looking at the next one. Here's angle L with 1 marking and angle N. No. First off, because angle N has 3 markings. And secondly, because which angle N are you really talking about? Are you talking about this one on the left, this one on the right, this one on top, or this one on bottom? I don't know which one you're talking about. But regardless of which one you're talking about, it has the wrong number of markings. This one says L and Q. That's okay. They have the same number of markings. They're congruent, so we're okay with this one. All right, let's look at M and N. Here's M with 2, and here's N. Again, which N are you talking about? Neither one would work because the 2 ends that have markings have 3 markings and not 2. So it has to be that one. See how we did that? Okay.
That was actually really easy.
Yeah, it's really, really easy. It just looked intimidating because there was a lot of stuff. So take a moment and write a note to yourself. When it's intimidating, go one tiny thing at a time. Okay? All right, I'm going to look for the next biggest one here. All right, which was this one? Find the measure of the angles. This is top of page 2. Find the measure of the angles. We're doing really good. We've only been on this review for 20 minutes and we're more than halfway done. You guys are doing really good. Yeah, it's really, really good. Yep. All right, I'm going to look at the diagram first of all. I'm going to start with angle 1. What do I notice? It's on the outside of this big triangle, but I don't know what this angle is. And I'm not asked to figure out what that angle is. But if I were to cover everything else up, what do I have right here? I have a 70, and then the angle number 1. But what do I have right here?
Yeah, it's the line, the base.
It's a line. It's a linear pair. These two added together equals 180. And so if these two together equal 180, and this is 70, what does the measure of angle 1 have to be?
110.
110, and we use the fact that they are a linear pair to do that. Looking at our figure, we're trying to get to angle 2. Hi guys, keep it on topic for me, please. Here's angle 2. We're trying to figure that out. I notice I have parallel lines. With these parallel lines, looks like comes a transversal. What is the relationship between angle 2, the one we want, and this one, the one we know?
Corresponding.
They're corresponding angles. So angle number 2 is 70 degrees because it is a corresponding angle. Now that I have all these down, I know this is 70, this is 80. How do I find the measure of this angle? Add both and subtract that from 180. 30. This was using the triangle angle sum. This question did not require you to justify, and so just giving the numbers is fine. But I went through and gave you the justification, so when you go back to study, you know why we did these things. We'll be looking at the bottom of the page next. All right, here's another one that 8 of you voted on looking for. Yes, ma'am. Angle 1 was 110 degrees by linear pairs. I think the theorem is like the supplements theorem. I don't know. I know this one better as they're linear pairs. And linear pairs do this. All right, we need to classify the triangle by its angle and by its sides. I can definitely classify it by its sides. It's an isosceles. Look, I've learned how to spell it. Aren't you proud of me? Woo! What do you know about the angles in an isosceles triangle? What do you know about the angles in an isosceles triangle? Which ones? The bottom one. This one?
Yes, and
And the one on top. These are called the base angles because they're opposite the legs, and base angles are congruent. Which means if this angle is 20x minus 10, then this angle is? And I need to find x. I need to find x because only knowing the value of x will tell me what the measures of those angles are. It looks like all the angles are acute, but the drawing could be lying to you. And if the drawing is lying to you, then this thing could be something else. Okay, so let's go ahead and let's solve for x. Once again, using my triangle angle sum, I would write this angle measure plus this angle measure plus this angle measure equals 180. And now I solve this equation for x. I'm going to combine like terms. I'm going to combine the negative 10 with the negative 10 with the plus 4. Negative 10 minus 10 is negative 20, plus 4 is negative 16. Okay, I'm going to combine these like terms. I have 20 x's plus 20 more x's plus 9 more x's. I am either a bad girlfriend or have a poor choice in boyfriends, girlfriends, I don't judge, to have 49 x's. Going to add 16 to both sides. When I add 16 to both sides, I end up with 49x equals 196. Divided by 49. Someone help me out with that multiplication.
3.
3?
Nope.
4. Okay. And I'm believing them because they had their calculator apps out.
My brain.
Okay. All right. So it says show the steps needed to solve for x, and so all of this is answer B. But now I need to go back up and classify this thing by its angles. So that's going to require me to substitute in and figure out the measure of each angle. 20 times 4 is 80. 80 minus 10 is 70. So this angle is 70. This angle is 70. That means this angle must be
20.
40. Well, if we're not sure, we could always come back and do this. 9 times 4 is 36. 36 plus 4 is 40. All right, so what kind of triangle is it by its angles?
Cute.
Acute. Why?
They got acute angles.
Because we have all acute angles. Very nice. We're doing fantastic. We're approaching the 30-minute mark, and we only have, there's only 1, 2. But number 2 is almost exactly the same as this one, number 5. Do you want to see me walk through this one, number 2, or do you feel comfortable with it now?
Yeah, I think we did.
Feel comfortable? Okay. So then now let's look at this last one. We're going to classify the triangle by its angles and by its sides. And we've been asked to classify triangle ABC. There's a lot going on in this picture, so I'm going to highlight the sides of ABC. So I'm going to go from A toward B, toward C, back to A. That's the triangle that I'm looking at. Looking at this triangle, I notice that I have a right angle right there, which means what kind of triangle is this? A right triangle, which means A and B is no longer one of my valid answer choices. I'm stuck between C and D. Scalene or isosceles? In order to be scalene, what do we need to have?
No congruent sides.
No sides congruent, no congruent sides. Okay, and for isosceles,
At least 2 of the sides.
we need to have 2 sides that are the same. 2 sides congruent. All right, looking at this figure, I have this little piece has the same measure as this. I have this one piece has the same measure as this, but this whole thing is 2 of those. Are these, does this triangle have any sides that are congruent?
No.
No.
So it would be C.
Very nice. That's all we had for today. Thank you.